Okay, this lesson is about the substitution method when solving a system of linear equations. This is one of my favorite methods to use. And basically what we're doing is we're going to be taking a value and substituting it into one of the variables. So let's take a look at this first system we have here. Notice that the system that I have doesn't necessarily look like many of the others we've been working with. Most of the ones will have our x's lined up, our y's lined up, and our constants lined up. Well, this one is just a little bit unique. It's still two linear equations, which creates the definition of a system. So let's go ahead and look at this. This is a perfect example of when you would want to use the substitution method to solve a system. Notice how in my second equation is y equals -8. This is the perfect situation where you would want to use this method over another method. Now, what we're going to do with that y, -8, is we're going to take it and we're going to substitute it in for the y in the first equation. Let me show you what it's going to look like. I'm going to take that first equation and instead of writing a y, I'm going to write parentheses -8. You just did the substitution method essentially. Now, let's go ahead and simplify it. -6x minus 40 is equal to -22. Now, you can see that we don't have a y to work with anymore. It's just kind of like the second half of solving every other system. You're trying to eliminate one of those variables, which we did. So, -6x is equal to 18. And if I divide both sides by -6, that's going to give me x is equal to -3. And so now you have your x of your solution. And you guessed it, the way that you get your other variable is you substitute that x value back into one of the equations. Obviously, we only have one option where we want to substitute the -3, and that's going to be the first equation. So I'm going to take that first equation, and I'm going to substitute -3 in for x. And you can see what that does is it leaves us with only one variable to solve for. So, I'm just going to go ahead and finish this one up here. So we have 5y is equal to -40. Divide both sides by 5. That's going to give me y is equal to -8. And there you have it. There's your solution. So we didn't use elimination and we didn't graph this, although we could. If we really wanted to, we could take these and graph them on a coordinate plane and we'll get the same exact solution or the same exact intersection point. And like we said before, a one solution system will give us a consistent and independent system. Okay, let's try another one now. This one is a little bit harder. Not really harder, but it's just a little bit more involved. Okay, here I have two equations in slope-intercept form. Now, if I really wanted to, I could put these into standard form, or at least move my x's over to the left, and then I could use the elimination method. That would be perfectly fine. Or I could even take these two and graph them. It's perfectly fine. But for the purposes of this lesson, we're going to use the substitution method. Okay, so what we want to do is we want to take one variable and substitute it into the other. Now, this is not necessarily the best example for substitution because it's not like the first where you have a nice, easy number to substitute into another variable. So for this one, what I would do is I would take either the first or the second y and substitute it into the other. Let me show you what that's going to look like. So I'm going to substitute the bottom y into the top y, which is going to give me something that looks like this. -2x minus 1 is equal to 4x minus 19. I essentially took that y and substituted it right into the other one. So in this one, it's really just setting one equation equal to the other because y is going to equal the same thing in both the top and the bottom equation. So now what I want to do is just go ahead and simply simplify it. So a couple of things I could do here. I'm going to go ahead and start by adding 2x to both sides. But this is just a multi-step equation, so you can go any avenue that you'd like. And then I'm going to add 19 to both sides. So that's going to give me 18 equals 6x, and I'm going to divide both sides by 6 to give me x is equal to 3. There it is. So my x is equal to 3. Now I have to go and find my y. I could substitute my y back into either one of those equations. Doesn't matter. I'm just going to go ahead and stick with the top one. I think that'll be fine. Y is equal to 4 times 3 minus 19. So y is equal to 12 minus 19. So y is going to equal -7. And that is my solution to my system. This is a consistent and an independent system of equations. Okay, let's look at some more examples. Okay, so this is another really great example of when you want to use the substitution method. It's just kind of nice. And the reason it is, if you look at the second equation, you can see that y, he doesn't have a coefficient in front of him. Well, I mean, he does, he has a -1, but it's kind of like, I mean, it's 1 or, 1 and -1 are kind of easy to work with. So I'm going to use that as the basis of my problem. What I'm going to do is I'm going to take the top y and I'm going to substitute it into the bottom y. Let me show you what that's going to look like. 2x minus, now remember, y is equal to this chunk right here. So I'm going to say, all right, 4x minus 3 is equal to 1. See what I did there? Okay, I always use parentheses because watch what's going to happen here. What I did was I substituted that in for the y, so now I have to actually simplify this by distributing. There it is. Go ahead and simplify this down. And I'm going to get x is equal to 1. Okay. My pen keeps it's not working, so sorry about that. Okay. Now that we have our x, let's go ahead and take that x and substitute it back into either the original problem or the second problem. It doesn't matter which one. I'm going to go ahead and put it into the first one. So y is equal to 4 times 1 minus 3, and that's nice and simple. 4 minus 3, that's just going to give me 1. So my solution to the system is going to be 1, 1, consistent and independent. Okay, the next example, this might look a little bit better to use the elimination method for this one, which is perfectly fine, or you could graph it. Either one is perfectly fine. But because this is the substitution method lesson, I'm going to go ahead and use that method. So I kind of like using the substitution method on this problem because if you look at the original equation, or the first equation, you can see that I have an x and a y, and it doesn't have a coefficient in front of it. And that kind of tells me that this might be a really good problem to use this method. So I'm going to take this top equation, and what I'm going to do is I'm going to solve it for one of the variables. I'm going to solve it for the one that's easier to solve for. And you're probably thinking, oh, look, x is probably easier to solve for because all I would end up doing is adding y to both sides. So I'm going to change it into x equals, and then I could do 5 plus y, or I could do y plus 5. It doesn't matter. But there you just got x all by itself. So now what I can do is I can take that x and I can substitute it into the x in the second equation. If I do that, it's going to look something like this. 2 times x. Well, remember, x is equal to y plus 5. So I'm going to say, okay, parentheses, y plus 5. And then I'm going to finish off the problem. 6y plus, oh, I'm sorry, that's supposed to be an equal sign. My bad. Whoops. Equals 10. Let me go ahead and erase that so I don't cause any confusion. Whoops. it's still not going away. There we go. Okay, let's try that again. Equals 10. I'm sorry about that. Okay, now let's go ahead and distribute. So we have 2y plus 10 plus 6y is equal to 10. Simplify it out. I have 8y plus 10 is equal to 10. And then just keep simplifying it down. Y is equal to 0. Okay, and personally, I think the easiest equation to substitute this back into is that one that we created. So I'm going to say x equals 0 plus 5. Well, that was easy. So x is equal to 5. So my solution is 5, 0. It's consistent and it is independent. Okay, I think I have 2 more examples here for you. I bet you can guess what they're going to be. All right, in my first 2, I already have a variable that's solved for itself. So this is the perfect method to use for this one. So I'm going to go ahead and take that y, and I'm going to substitute it into the y in the second equation. So 10x minus 2. And now I'm going to take that y and what it equals, and I'm going to put it in parentheses. There it is. And set it equal to negative 8. Then I'm going to go ahead and distribute it and solve it just like I would solve a regular equation. Okay, and 10x minus 10x. Well, that's going to eliminate those, which is going to leave me with 10 is equal to negative 8. Well, we know that those are not equal. Oops. There we go. They are not equal. So just like all the other systems of equations we've done, when you have a false statement, that is going to give us a no solution answer. There is no solution to the system of equations, which means that these are 2 parallel lines. When you have a no solution, you're going to have an inconsistent system. Okay, in our last example, this is again a perfect system to use substitution with, although elimination looks pretty good as well. The reason I said it's good with substitution is that this x down here is by itself, or meaning I just have a coefficient of 1. So before I start this one, all I'm going to do is I'm going to get that x by itself. So essentially what I'm doing is subtracting 6y from both sides. That will give me negative 6y plus 8. But now I have my x by itself, which is what I want. Now I'm going to take that x and I'm going to substitute it into the x in the numerator. So 2 times my x, which is going to be negative 6y plus 8, plus 12y is equal to 16. I'm going to go ahead and simplify this all down. Negative 12y plus 16 plus 12y is equal to 16. My 12y's are going to eliminate there, and I'm going to be left with 16 is equal to 16. So when you're doing a substitution problem and you get this type of answer, just like the other systems, if it is a true statement and those 2 are equal, this is going to be an infinitely many solutions problem, meaning that there are 2 lines that are exactly the same, that are lying right on top of one another. This would give us a consistent system, but because there are many answers, it would give us a dependent system as well. All right, so hopefully that was a lot of examples for you showing you the substitution method when solving a system of linear equations.